Hey, what's up? It's your old pal, Mr. Cook, and we're working on the Unit 8 probability review. We've already made our way through the first page, front and back, and then the first half of the second page, so let's do the back part of it. So this is the last group of problems, and it looks like they all have to do with data tables. So this section is pretty easy as long as you know how to fill out a data table and read it. But even that is not that difficult. If you just practice a couple of them, the answers are right there in front of you. Okay, so looks like on the first one, number 13, we got to put together the data table. It says, in the math class at a school, 512 students took the summer review course. Of those students, 341 of them got an A. Of the 171 students who did not take the review course, 21 of them got an A. So then you just fill out like the data table, especially like the totals. The totals help you out a lot with this. Okay, so 512 students in total took the summer review course. So the total that took the summer review course is 512. And of those 512, 341 of them got an A. So 341 got an A. So how many didn't get an A? All you got to do to find that number is just subtract from these two. So it's 512 minus 341, and that gives you 171. Okay, then it says, of the 171 students who did not take the review course, so the total number that did not take the review course, that's 171. Of those, 28 of them got an A, so we put 28 over there. And then to find this number that's in between, we just take 171 and subtract away 28, and we get 143. So now all you got to do to find the totals for everything is just add them straight down. So 512 plus 171 gives you 683. 171 plus 143 gives you 314. And then 341 plus 28 gives you 369. Okay, so now we've got our total table filled out. Now let's answer some questions. So using conditional probability, determine if taking the review course is independent from getting an A. So what they're talking about is that probability formula with conditional probabilities that states that if I have the conditional probability of one event given the other, it should be the exact same as the probability of the event taking place. So let's go ahead and pick one from each of these. So let's just say that this is event A, getting an A, and then event B is taking the course. So what we're going to do is check to see if those probabilities are the same. So what we're going to do first is do this probability, the probability of getting an A given that they took the course. So we're only going to deal with the students that took the course, so just these students here. So what is the probability of getting an A? So the students that took the course and got an A were 341 of them out of a total of 512 students. So what we need to do is compare and see if this is the exact same thing as just the probability of A happening. So how many students got an A? 369 of them out of a grand total of how many students? 683. So let's check and see if these probabilities are the same number. So let's find this one first as a decimal. 369 over 683. That gives me a decimal value of 0.5403, right around there. Now let's see what this one's going to be. So 341 divided by 512, that gives us 0.6660. That's a crazy number there. So are these two numbers the same? No. And if they're not the same, then that means that it is dependent. If they were the same, then that means that they are independent of each other. So these are dependent values, or dependent events. All right, next, we're going to put together a table using the information in a survey of 500 people. So 260 people prefer chicken and lemonade, and then 190 people prefer steak. Of the 90 people who prefer soda, 50 prefer chicken. So this is going to be like chicken and steak for the meats. So chicken, steak, and then the two drinks are lemonade and soda. And then don't forget about your totals as well. Okay, so 500 total people took this whole thing, so that's going to be the grand total, which goes over there in the corner. 260 people prefer chicken and lemonade. So chicken and lemonade, that'd be 260. 190 people in total prefer steak. So steak total is going to be 190. And then of the 90 people who preferred soda, so soda is going to be 90. 50 of them also preferred chicken. All right, so let's start filling in some of these values here. So if we take 50 and 90 here, so the difference between those is 40. So 50 plus 40 would be 90. So if I know this total is going to be 190, if I have 40 here, if I subtract it from 190, I get 150. If I add up 260 and then also 50, that gives me 310. And sure enough, 310 plus 190 gives me 500. And then 260 plus 150, that's going to be 410. And 410 plus 90 is 500. So everything checks out over here. And that's our data table. What's the probability that a person prefers lemonade? So there are a total of 410 people that prefer lemonade out of the grand total of 500. So then, you can reduce it a little bit further because the zeros can get knocked off there. So 41 out of 50 would be your answer. What's the probability that someone prefers chicken, given that they prefer soda? So we're only dealing with the people that prefer soda, so just these people. So that's a total of 90 of them. Of those 90, how many of them prefer chicken? So that chicken is going to be 50. So 50 over 90, then the zeros cancel out, so we just have 5 over 9. So that's the probability for that one. All right, now moving on to 15. They already put the data table together for us, so we can answer these questions pretty easily. So let's see here. What's the probability? All right, so randomly selected student is a sophomore. So that's the probability for A, and then female for B. So what's the probability that the student is a sophomore? So how many sophomores are there? There's a total of 4,000 of them. Out of a total of how many students? 16,112. And then, you can reduce that as much as you can. Let's see if it reduces on our calculator. 4,000 divided by 16,112. Yeah, cool, it does. So 250 out of 1,007. All right, what about the probability of B? So B is the event that they're female. So how many females are there? There's 9,184 out of the total of 16,112. So then I just use my calculator on that one as well. 9,184 divided by 16112. And then change that into a fraction. Cool, so that one worked also. 574 over 1,007. So those are the two probabilities for the first ones. What about the probability of the intersection? So that means that the person is both a sophomore and a female. So sophomore, female, that's going to be 2,280 out of the 16,112. Now let's go ahead and see if that'll reduce on the calculator. So 2280 divided by 16112. Then change it to a fraction. Yeah, it did. Wow, cool. 15 out of 106. And then let's do the last one, the union. So it'd be A and also B. So what we do for the union, if you remember, is that we take both the probabilities. So the probability of being a sophomore, which we already found, which is 250 out of 1,007. And then also we take the probability of B, so we add that up also, so 574 out of 1,007. And then we subtract away the intersection, so where they overlap, because otherwise it'll get counted twice. So 15 over 106. So then we just type this into our calculator and then see if it'll reduce as a fraction. So we have 250 divided by 1,007 plus 574 divided by 1,007, and then minus 15 over 106. And then change it to a fraction. Yeah, it works out. Neat. So 1363 out of 2014. And you can write down the decimal values for all these that I've had, and those will probably be fine as well. I'm sure that your teachers will accept them. I just wanted the exact values rounded down. Okay, so that is it for the review. As you can see, it really doesn't take too long to get through like a ton of these problems. Let's be honest, like the hard part is just like reading through these and making sure that you're picking up on the little subtle things that they're mentioning. Just make sure to ask questions about this stuff if you're not understanding anything. Most of it's just multiplying, dividing, or adding or subtracting. So just, regular old arithmetic, but you need to know like how to apply it, like when to multiply and all that stuff. And I guess you also need to know where to find your combinations and your permutations. Remember, that's just in the math button, and then probability. It's in different places as well in other calculators, like in these, it's like the PRB button that has it, you know. So just make sure that you know where that is, and you should be just fine for the test. Okay, but if not, make sure you reach out to your teacher and make sure that you get the help that you need. That's it for the review. Good luck on your test.